This tutorial explains about a scalar field using MATLAB. So um, first of all, let's look at the example of 1D plot. Let's say we create a line space from -3 to 3, and let's maybe create 10 points. So this basically gives me 10 points equally spaced from -3 to 3. And I create a function f which is x times e to the power minus x squared. And I can plot it, and this gives me a one-dimensional field, which means I have a value of function f at different values of x. So it's in a single variable. You can increase it to 100 to see a little bit more detail on what this function looks like. Now let's say I actually add another axis to this. So it's x and y, and I make it a two-dimensional scalar value. So in other words, I have f as a function of x, y, but it's x times e to the power minus x squared minus y squared. So now I can use what we call mesh grid to create a two-dimensional grid. So to elaborate this a little bit, so let's create an array from -3 to 3 with a spacing of 1, and let's see what is the size of x and size of y. As you can see, they're both 7 by 7 matrices. So -3, -2, -1, 0, 1, 2, 3. That's what this gives us. If we look at this, this gives us -3. But then mesh grid, what mesh grid does, it creates an array that goes from -3 to 3, and there are several rows with the same values. And if I look at the y values, it gives -3 to 3 in the other direction, so columns. So x's are rows from -3 to 3, and y's are columns. And now I can find my function value. So basically, if I combine x and y in this way, let's say, I'm getting all possible ordered pairs of x and y. So I'm starting from -3, -3, -2, -3, -2, -3, -1. So I'm creating a space, a two-dimensional space, where all the values of x and y are present. And I can now find the value of f at each of these points, and there will be same number of values of f. So now let's use the surface command to plot this. In surface command, we put the x coordinate, the y coordinate, and the value of the function. So this is a two-dimensional surface. Of course, we didn't have enough values. We only had 7 values, but we have x coordinate, y coordinate, and the value of function at different ordered pairs of x and y. To improve the look, now let's go back here and increase the spacing to maybe 0.1 and see what this looks like. And then plot the surface again. So you can see now it has a much denser value and much smooth. Now I can also look at f as an image, because if you look at f, it's a 61 by 61 matrix, so it can be treated as an image as well. And for that, we use image sc command, and we put the value of the array as an input, and it creates a 2D view where the color is the third dimension. So the values of f are ranging from blue, which is low values, to red, which are high values. Now you can look at what those values are by putting a color bar next to it, and now you can see it goes from -0.4 to always almost 0.4. Now let's try to put everything together. We can put a subplot for the surface and then another subplot for the image, and you can see this gives you an interesting insightful view of the function, a 2D function, which is giving us a certain shape, and then we can see what it looks like as an image. Now, the same idea can be extended through to 3D space. So imagine we have a function which is a function of 3 variables, and as you can see in XYZ coordinate system, if we want to plot this, it's actually a 4-dimensional value, because at each 3-dimensional point there's a value of the function. And for this purpose we still use mesh grid, but we say, hey, give us a third coordinate, and let's run this and see what it looks like. Now if you look at size of x, it's a 3-dimensional value, and this should be it's 13 by 13 by 13. And if you look at the size of y, it's also 13 by 13 by 13. And so now these x, y, z form ordered triplets in 3D space. And if you want to view them, you can use the scatter plot in this way and view what this space looks like. And you can see that now all of these x, y, z values are actually a grid in 3 dimensions, and at each point there's a value of the function. And if we compute that value of the function itself, that is also 13 by 13 by 13. And you should be able to imagine now that if I take one slice of this 3-dimensional volume, then that should look like what we did it for the 2D case at z is equal to 0. But we can also do a scatter plot with some color, and here is how you run that, where the 4th variable is just a scaling factor, how big I want these circles to look like. Let's use the value 10, and then the last value is the value of the function at these 3 coordinates. And when we run that, now you can see the scatter plot in the 3 dimensions. You can see that those low values and high values are here, and then as you go away from those points, you have lower values. Now we can look at this, we can pass slices through this and see what those values are, and for that we can use the slice command. So it's the same concept. We have x coordinate, y coordinate, z coordinate, and the value of the function, and then I can pass a slice through, say, 0. I can give it how many slices do I want to pass. So let's say I want to pass a slice along the z-axis. So nothing along x-axis, nothing along y-axis, but along the z direction I want to pass a slice at the origin. So this is a slice the way we looked at in the 2D, just like a 2D plot. But I can also say I want to pass a slice at 0.5, 0, and minus 0.5. So it'll give me 3 slices. I can also say, well, I want to pass a slice in the x-axis direction as well at maybe minus 0.25 and 2. So now it has also passed 2 more slices through my volume. So the idea is to get a visualization of what the function looks like if I pass some slices through the function. I can also create my own slice. As you can see, these slices are along the x direction or z direction, and you could have one along the y direction as well. Actually, let's do that. Let's just pass one slice along each direction at origin, 0, 0, 0. So this will give me 3 slices, and that basically gives you a little bit idea about what the volume would look like. But let's say we want to pass a oblique slice through this function. To do that, we'll have to create our oblique plane. So let's create a two-dimensional plane. So again, if you know what mesh grid is, make sure you read the help on mesh grid. This is creating a two-dimensional array of x and y ordered pairs, and then I define a plane which looks like this. So if I just type the surf command for xs, ys, and zs, it's this surface. This is the surface as we learned in the 2D part of the tutorial. And now if I want to look at the function along this surface, I can type my slice command where I have my x, y, z values and the value of the function at all of these three along these three coordinates. And then I tell it that I want to look at this function along this surface that is defined by xs, ys, and zs values. And now you can see that this is the same function but along this arbitrary plane. Now here is a fun another fun surface. I would suggest you define this surface and then try to see what the slice along this surface would look like, but also try to just plot this surface as is. So this concludes the tutorial. In this one, basically what we have learned is that if we have a scalar field, which means a single value as a function of position, we can use mesh grid to create that space and then find the value of the function at those points. And then we can use a scatter3 function to visualize it. We can also use slice function to visualize the three-dimensional scalar field.